my mind for a while.
Yeah, no, yeah. It's
Yeah,
good.
because I asked you to be on the panel, and you were kind of like, I'm drawing a line.
I decided I could do one. I could do one thing. And this has been fun because I'm excited about this because it's been a neat opportunity to interact with students.
The sessions that we've had with the speakers.
Yeah, no, I think it will be. And the benefit is like, the geographic diversity is impressive. It covers a huge area, which is really cool, especially since Rachel has African expertise.
I'll stand over here. Welcome once again to Dickinson College and Science-Based Choices for Climate Action. I'm recognizing quite a few faces who are here for yet another session. Thank you for investing this much time with us. I'm also seeing quite a few new faces in the audience. Thank you for joining us for this. Welcome also to our remote audience. We've got, I'm not sure how many are actually watching, but we had over 3,000 people register for this symposium from 50 different countries to give you a sense of the scale and scope and diversity of interest. We'll have opportunities for you to ask questions during this session. If you're here in the audience, when we get to that point, raise your hand to take a question. Because we're an undergraduate institution, we give initial priority to questions from our students. We'll also take questions from the virtual audience. You can type your questions into the chat on YouTube Live at any time. You don't have to wait until we call for questions, but that's the way you can interact, and we'll be monitoring those and taking questions from the remote audience that way. We have, in case of an emergency, there's an exit off to my left this way. There are exits at the top, at the back on the right and left, and there's a handicapped accessible exit through the drapes, which maybe is not the best plan, but we will get those out of the way should that need arise. Now I would like to invite Professor Maggie Douglas, the moderator for this session, and she can come to the podium in here, and she'll introduce or have her panelists introduce themselves to you, and enjoy the session.
Excellent. Thanks very much, Neil, and thank you all for being here. It's exciting to see a great turnout here in person, and it sounds like online as well. And we are here to spend the next hour exploring the important and wide-ranging intersections between climate change, water, and food. So it's a big task for an hour, but we're going to do the best that we can. Before we get started here, I'm going to steal something that Neil used in the last session, and I want to give our panelists an idea of who's in the audience here. So students in the audience, give a wave if you are currently in a course that is studying some aspect of food or water systems. All right, seeing a lot of hands over there. How about, do we have any student farmers in the audience? Seeing a few, current or past. Looking up at Audrey over there, yep. Over there, yep, seeing a few. How about students who are involved in community water monitoring through alarm? Seeing a few of those hands. Okay, so that's excellent. And I'm really excited about this session because we have a really impressive interdisciplinary panel of scholars joining us, and I'm going to take a few minutes here to introduce them to you before we get started. I want to emphasize that two of our panelists are joining us from the other side of the globe, so it is like nighttime where they are, so it's very generous of them to stay up in the night to join us for this important topic. And all of these panelists contributed as leaders and as authors of the IPCC's Working Group 2 report, which is focused on climate change impacts, adaptation, and vulnerability. So I'm just going to walk you through a little bit about who they are and their expertise, and I'm going to invite our panelists to give a wave as I introduce you so that our audience here knows who you are. So we'll start with Dr. Aditi Mukherji is a principal researcher at the International Water Management Institute and previously was a theme leader at the International Center for Integrated Mountain Development. Her areas of specialization are groundwater governance, the energy irrigation nexus, climate change adaptation, and community management of water resources. She has a really impressive geographic scope in her research. She has worked in South Asia, Central Asia, and the Nile Basin. And Dr. Mukherji is a human geographer with a PhD from Cambridge University. Okay, next we have Dr. Toshihiro Hasegawa, who is manager of the Climate Change Adaptation Division at the National Agriculture and Food Research Organization in Japan, focusing on crop physiology in response to environmental change. Dr. Hasegawa's current research focuses on rice yield and quality under climate change using free air carbon dioxide enrichment experiments, which you can see in his background on Zoom right now, and also using crop modeling in his research. So in addition to his contributions to the IPCC, he is leader of the rice team for the Agricultural Model Intercomparison and Improvement Project. And then finally, we have Dr. Rachel Bezner Kerr, who's a professor in global development at Cornell University with expertise in sustainable agriculture, gender, climate change adaptation, food security, and nutrition. Dr. Kerr co-authored the 2019 report on agroecology for the United Nations Committee for World Food Security, a really impactful report. And she holds a PhD in development sociology. Her work is primarily based in Tanzania and Malawi, where she has worked with farmers for over 20 years. So to begin our panel, we're going to set the stage for the discussion by getting sort of a high-level guided tour through some of the key findings of the most recent IPCC report related to food and water. Our panelists are going to talk to us about mitigation, which as a reminder means getting at the root cause of climate change by reducing greenhouse gas emissions. They're going to talk about adaptation, which is protecting ourselves from the impacts of climate change. And they're also going to talk about this interesting concept of maladaptation, which we heard a little bit about earlier today, which is when an action actually makes people more vulnerable to climate change rather than less. So each of our panelists is going to share a few slides to kind of walk us through these key findings. And so we're going to start with Dr. Mukherji, who will address the water-related risks, mitigation, and adaptation, and then move to Dr. Hasegawa, who will talk to us about the food-related findings in the report, and then finally to Dr. Kerr, who will help us think through the equity considerations that occur in the food and water sectors. So with that, I'll hand it over to take it away, Dr. Mukherji.
Thank you so much, Dr. Maggie. I'll just share my screen and I'll try and be brief. First of all, thank you for this wonderful opportunity to be here and talking to the students. Nothing as exciting as that. I would try to summarize, give a high-level summary, as you said, Maggie, around the water-related findings of the IPCC assessment, of which I was one of the coordinating lead authors. We were a team of 2 coordinating lead authors, both women scientists, and then we had 10 other scientists who were lead authors. So it was a very diverse team based on a whole lot of disciplines, right from hydrology to human geography. Overall, what our chapter concluded after the assessment is that climate crisis is water crisis, yet water is largely neglected in climate change negotiations. For example, the last COP doesn't mention water even one time. And the reason we say this is that our assessment shows that climate change has led to changes in all components of the water cycle already, and this is in a 1.1 degree world. And all these changes are going to be intensified in a future warmer world. And we know from our commitments so far that we are headed towards a 2.7 to 3 degree world if we don't ramp up mitigation actions. So as a result, what has happened, because water is used in all sectors and agriculture in particular, there has been impacts mostly negative in almost all sectors through things like floods, droughts, rainfall variability, etc. And we also find the majority of the people affected are in the global south because they most often are in climate exposed occupations like agriculture. We also found that based on a meta analysis of a systematic scoping review of all documented adaptations since 2015, that majority of the adaptation are in response to water-related hazards. So people are responding, and particularly in agriculture sector, but also in urban, due to these water-related hazards such as floods and droughts. And they're also using water as a means of adaptation. And a lot of this includes rainwater harvesting, irrigation, better soil water management, etc. And then finally, this will be the decade of mitigation, but a lot of these mitigation ones, for example, even nature-based ones like afforestation, etc., would have deep water impacts or bioenergy crops. So that's, they also would have high water footprint. Now, very briefly, what we are finding is hundreds of millions of people are experiencing changing precipitation. More people are seeing wetter climates than they did, wetter conditions than they did 50 years ago. This is like what they're already seeing. We're also seeing that heavy precipitation has increased over many areas. I'm not reading out the numbers, they're here, and happy to share my presentation later on. And some of the examples are last year's huge floods in Europe as well as this year's flood in Pakistan, and both of them have a clear climate change fingerprint apparent in them. We are also finding that dry spells have increased in some areas but decreased in others, but mostly longer dry spells are being experienced by more people than shorter dry spells. And all of these have actually direct impacts on food and agriculture, as Toshi and Rachel will talk after me. So similarly, flooding is projected to change with ongoing warming, and so much of the flooding actually also has non-climatic things, as in like a lot of the flooding impacts are due to socioeconomic and vulnerability reason. I'm sure one of my co-panelists will talk about it, but what this shows is that flooding is projected to change with global warming and higher flooding and higher levels of emissions. So that's kind of known. Then we also similarly the same for agricultural drought. I mean, every like 1.5 degree would be better than 2 degree when the drought situation becomes worse, and 4 degree we are seeing a world which will experience a lot more drought. And you can see that many of those droughts would happen in some of the largest agricultural regions in the world. But more importantly, this is not strictly from IPCC, but another regional assessment we did at the EC mode for the Hindu Kush Himalayas, but even 1.5 degree would be too hot for the Himalayas. And why Himalayas matter for the part of the world I come from, South Asia, Himalayas is the source of all the rivers we have. Actually, in Asia, 10 of the major rivers in Asia comes from the Himalayas. And where we find that even 1.5 degree would be too hot, given that like at 1.5 degree world, almost 36% of the ice and glacier volume is projected to be lost, and which will be 50% by a 2 degree world. So basically, we are not on a target to reach 1.5 degree anyway, but even 1.5 degree would be very difficult for some of these parts of the world. And Himalayas is one of them, as is small island developing states that we say in the paper. Then climate risks are mediated through non-climatic factors, and this is a lot of it is around. I think this is something new about the working group 2 report this time. There has been a lot of focus on vulnerability, underlying vulnerability that is making this climate impact so much worse. Now, finally, what do we know about adaptation? A lot of adaptation is happening, but documentation is not there. We know some adaptation is largely fragmented. Most of the adaptation is taking place at local level, and we don't have really very good evidence of absence. We don't really know how effective those adaptations have been. Some have been effective, but that kind of database is still missing. And here again, to reiterate, we are finding that water is central to adaptation, and a lot of the documented adaptation is related to water. So we do an assessment of some 16 major types of adaptation, and just my final slide is, I think this is incredibly important and something that we emphasize over and over again, particularly in the water chapter, is that for one, we don't really know how effective adaptation has been in reducing climate risk. Adaptation has had many, many benefits, livelihood benefits, ecological benefits, etc. But the risk reduction part is still a bit of a question mark because we simply don't have good enough evidence. And the second part, very important, is that all the evidence that we have shows that whatever adaptation we have and howsoever much they may be working now, they become much less effective at a higher level of warming. So majority of these adaptation that we looked at improved cultivars, we looked at on-farm irrigation, water management, changes in cropping pattern, water and soil moisture. A lot of these are in agriculture sector. Majority of them become less effective if global warming continues. So with that, I would kind of, this is my last slide, where this is the last sentence of the summary for policymaker for the Working Group 2 report, which is saying that the scientific evidence is unequivocal. Climate change is a threat to human well-being and the health of the planet. Any further delay in concerted global action will miss the brief, rapidly closing window to a secure, livable future. Thank you so much, and back to you, Maggie.
Great. Thank you. So a remarkable amount condensed in a short space. And so I'll invite now Dr. Hasegawa to share his presentation with us to give us an overview of climate impacts in agriculture and food. We cannot hear right now, Toshi.
Sorry, just a minute.
There it is. Okay, great.
Let me share the screen again. How's this?
Yes.
Okay. Okay. Thanks, Maggie, and thanks everybody. I'm really happy to be here. I'm one of the coordinating lead authors of Chapter 5, co-authored with Rachel, just here. Chapter 5 is about food, fiber, and other ecosystem products. And this provides a global assessment of climate change impacts and risks to agriculture, forestry, and fisheries, and aquaculture, and as well as adaptation solution and limits. And this is our chapter. And Aditi is chapter number 4, that's water, and here is food. And there are basically, I want to convey 3 major messages. One is about current ongoing climate change affecting different sectors of food, related to food sector. And climate change impacts are already stressing agriculture, forest, fisheries, and aquaculture, especially in low and mid latitudes. And this increasingly hinders efforts to meet the sustainable development goals. And so this is a major message, and this climate change is already here, and that's affecting different sectors. And what are the major impacts that we're seeing? And as Aditi explained, this increased extreme events, including droughts, floods, and heat waves, have put millions of people at risk of acute food insecurity, and particularly in Africa, Asia, Central and South America, and small islands, and the Arctic. So this is the first time we use this acute food insecurity in this report, as opposed to chronic food insecurity. And these are really often frequently occurring these days, as you can see in many media coverage. And for the long-term impacts, also this is the first time we say human-induced climate change has slowed the agriculture growth over the past 50 years. All the agriculture productivity has grown substantially for the past 50, 60 years. But we have found that we have evidence that human-induced climate change has slowed the growth. So that's hindering our efforts to meet the sustainable development goals as well. And the effects are not even, and vulnerable groups such as women, children, low-income households, indigenous or other minority groups, and small-scale producers they are at a higher risk. And this is somehow a very similar conclusion done by Aditi and the other chapters. And this is ongoing climate change. What are the future? And risks are projected to escalate with every degree of warming. So that's another key message of the whole report and as well as our food chapter. And we also identified some key risks in food-related sectors. One is that very commonly observed food security and nutrition, that's acute and chronic food and feed shortages. And that's one key message. But I also found some other key risks, such as food safety and dietary health. That is, the climate change is already or projected to affect the food poisoning or worsen food poisoning and pollutant contamination. And that undermines the human health. And limited access to dietary diversity. This is also leading to malnutrition. And not just for the food production, but also livelihood of people in the food and ecosystem service sector. These are one of the main things. And we on your right-hand side, you can see this a little bit complex figure that's showing the complex nature of cascading and compounding effects of climate hazards that affect not just food yield and quality losses, but also other things like labor productivity, household income, and finally the food availability and consumption that leads to malnutrition or on the quality of life. These are new and a report that's showing that they're compound and cascading risks. Adaptation, I think Rachel will cover more on this effect, but adaptation-wise, we also seeing that the evidence for adaptation that's occurring. And adaptation is somewhat effective to some degree, but also the feasibility and effectiveness depend on the various things. That's very context specific. One of the key findings in our report is that this ecosystem-based approaches have multiple co-benefits. Probably that's one of the major issues today's discussion. But again, it's in line with the Aditi's conclusion. Without strong reduction in greenhouse gases, the impacts will be even worse and severe on food systems, not just water. So that's far from my side. Thanks, Maggie. Back to you.
Mm-hmm. Great, thank you. And then finally, we're going to hear from Dr. Kerr, who's going to give us an overview of how we can think about the equity kind of dimension in the food and water sector.
Thank you very much. And I'm really honored to be invited to this event and also to be sharing my panel time with such esteemed colleagues. It's really a delight to be with them again and to be sharing time with them. And I can no longer multitask at all, even though I'm in the correct time zone here. So, excuse me, there we go.
Perfect.
So I'm going to briefly touch on these issues, and these are core themes of our report, not just for Chapter 5, but in the summary for policymakers and in many of the chapters, including Aditi and the water chapter, and look forward to questions as after I touch on these issues. So we heard from Aditi that the global south is more affected by their greater, and from Toshi, that the global south has greater vulnerability to impacts in terms of extreme events and in terms of the anticipated and observed impacts. And so that's one source of injustice, because many parts of the global south are the least responsible for greenhouse gas emissions, and yet are anticipated and are already observed to experience much more severe impacts from the climate change impacts, and are often the least equipped to be able to address those impacts because of less resources available to do so. But in addition to that question of social injustice, there are also marginalized groups within both high income and medium and low income countries that are at greater risk. And many of these groups are already marginalized and disadvantaged. So Toshi highlighted women, indigenous peoples, other ethnic and racial minorities, and these smallholder producers and farm workers. And these groups vary by place, so they would differ based on location, who is at greater risk, but they are at greater risk from impacts. And so one of the findings of the report as a whole, and for the food system in particular, is that in order to have effective adaptation strategies, there needs to be very close attention paid to the way in which the adaptation approach is planned and implemented, and inclusive governance strategies that really involve marginalized groups and regions in the process from the beginning is essential if there will be effective adaptation strategies. And if the methods used are not inclusive, there is a risk of worsening climate impacts for these same groups and for these same regions. So this is a kind of core message. How adaptation takes place is really important. And in addition, there is a strong emphasis in the report on being attentive to diverse knowledge systems in implementing climate change adaptation strategies. And in our chapter, we did an assessment of indigenous knowledge and local knowledge as it applies to agriculture and food systems, and found that there are many different examples where indigenous knowledge and local knowledge provide really important adaptation strategies. And not only in terms of the sources of knowledge, but the ways in which adaptation strategies are rolled out should draw on diverse learning strategies and diverse sort of approaches, pedagogical approaches. So things like the use of the arts, participatory modeling, citizen science, community-based adaptation. So these are different strategies in terms of sharing information and educational programs that can really help to facilitate awareness and heighten willingness to take action and influence people's actions. And this is not true in one place, but this message is true for for adaptation as a whole. One of the examples we have in our chapter is seasonal forecasting that has been developed in pastoralist communities with drawing on and in collaboration with indigenous peoples and their knowledge systems, and using sort of participatory methods and dialogue to test and develop these seasonal forecasting methods. And this has been found to be effective in helping these communities adapt. So that's one example, but there are many examples in our chapter and throughout the report. And in addition to emphasis on how to be effective in adaptation, there is increasing evidence in the scientific literature of maladaptation in adaptation, including in food systems. And maladaptation is adaptation that results in unintended consequences. And those consequences can be increased greenhouse gas emissions, it can be ecosystem degradation, and it can also be things like worsening social inequities in a given location. And often the very same marginalized, disadvantaged groups that I mentioned in my first slide are worse off from maladaptation actions. So where there's maladaptation, those groups suffer more. And it's not always related to a particular technical option, but maybe the way in which the adaptation strategy is undertaken. So the governance, again, can be done in such a way that even if you have the right technical strategies in place, some people are left in a worse off position or the ecosystem is degraded. And one of the examples that we include for which there is considerable evidence, and this is highlighted in the summary for policymakers, is irrigation. So irrigation can provide important short-term adaptation strategies for sustaining food production. But if it's done in a location that is not appropriate, or if it's done in a way that is not taking the ecosystem into account, it can lead to things like soil salinization. It can lead to groundwater depletion. And I'm sure Dr. Mukherji could talk about this in greater depth than myself from the water perspective. But it can also, if it's not done in a way that's attentive to the social inequities in place, it can lead to a worsening, a widening of social inequities, particularly for smallholders who may not have the capital to be able to afford the infrastructure, who may not have the political clout to be able to access loans for affording the infrastructure. And so an implementation of irrigation in a given location may mean that they cannot compete with those larger landholders who are putting infrastructure in place for irrigation. And so they may actually lose their livelihoods. And there were documented examples of this kind of event taking place. So that is a very important message from the report to, yes, we need to implement adaptation now and at great speed, but we need to do it very carefully and thoughtfully, taking into account ecosystems, the local context, the local social, political, and economic context to ensure that we're not worsening conditions for people. And with that, oh yes, I have one example. So one of the other messages from the report is the need to integrate adaptation strategies. So not to just have a single sector or single climate risk focus, but to think about multifaceted strategies that take multiple sectors into account and differentiated types of risk. So I have an example here from the literature where you might have social protection programs that provide cash transfers to marginalized, vulnerable groups. And they may do things like build wells so that they have better access to water. So they're supporting regional infrastructure. And there can be mechanisms such as forecast-based financing, whereby in advance of an extreme event that is forecast, vulnerable groups receive cash that they often don't have at their disposal to be able to move quickly if they need to move, for example, if there's a flood or if there's a wildfire predicted. At the same time, so this is a shorter term strategy in an emergency event, but at the same time, there can be longer term strategies that are trying to build resilience in with vulnerable groups. So for example, supporting farmer cooperatives, supporting farmers learning how to diversify, which has a lot of evidence of strengthening resilience in food systems, ensuring that there are regional grain banks so that there's a steady supply in the case of food reductions, and then public procurement, whereby smallholders have their diversified foods purchased, and that food is then fed into things like hospitals or into schools for things like school feeding programs. So then you have kind of homegrown school feeding, which is strengthening child nutrition and school outcomes at the same time that you're providing strengthening livelihoods for smallholders, which is helping to build their resilience and helping to provide livelihood outcomes for more diversified farming. So this is a multifaceted and more complex set of strategies that is aiming at both short-term and long-term adaptation and multiple risks. And this is one example that is in the literature, but there are many other examples. And with that, I am looking forward to questions and discussion.
Excellent. Great, thanks to all of you. And I think that gives us all kind of a foundation that hopefully we can build on as we continue the discussion. I'm going to kick off the discussion with a few questions for our panelists, but I want to encourage all of you out in the audience to be kind of recording and keeping track of your questions. If you're in the online audience, to be submitting them, because we will try and also protect time to engage the questions that you have for this really excellent panel. I think where I'm going to begin is actually connected to kind of that last point that Rachel's presentation made about integrating approaches to adaptation. Yesterday, in our keynote from Deborah Roberts, she introduced the concept of climate resilient development. And one of the points that she brought up was this kind of reality check that in many places in the world, government's first priority is meeting people's basic needs. And of course, food and water are incredibly central to those basic needs, right? And so, and it was explained that sometimes that can be seen as an obstacle to undertaking ambitious climate action towards mitigation or adaptation, because there's a sense that those things are higher priority, right? But I think what's interesting about this group that we have assembled here is that you all contributed to the part of the IPCC report which points out the interconnections, both that climate change is having observable impacts on the food and water systems, and that it's predicted to do so even more in the future. And as Toshi pointed out in his opening remarks, there are important opportunities for co-benefits, right? Places where taking action towards climate adaptation could have side benefits for mitigation or for other societal goals. So I want to start out by kind of exploring that idea a little bit further. And maybe Toshi, I'll ask you to start us off here. But what do you think are some of the options that have the greatest promise to help us both adapt to climate change in the food and water sectors while also addressing some of these other needs?
Okay, thanks. First of all, thank you for that really great question. It's really hard to answer in a short minute. But what I'm firstly raised, one of the important points from our assessment is that we have not had enough sufficient and quantitative evidence to compare, say, which adaptation option works better than the others. So it's still hard to do. And we have different options available at the point. So I can't say, okay, this is the adaptation option that works really good for many aspects. But what we learned from the assessment is that some of the adaptations are really have some different co-benefits. And there are multiple ways you can show it, but as Rachel introduced. But one of the keywords from the common aspects of this co-benefiting adaptation is that the diversification, and diversification at very different levels. Like you can start from, say, mixed farming levels, if you have different multiple crops growing in the same place, or landscape levels, if you have rotation of the crops going on, or diversification about supply chain, not just for the producer, but for the consumer or retail levels. And those have very different aspects of benefits, not just including the risk hedging from the extremes, but also stable incomes, for instance, also the access to diverse food, and that gives you a better health in dietary. So those are the things that we are looking into. There are more of the benefits, but I think that's one of the keywords we found is the diversification that develops. That could include some agroecology adaptation. Thank you.
That's great, thank you. And I wonder, Aditi, if you have anything to add from a water perspective, what you see as some of the key interventions that have co-benefits.
Yeah, no, that's a very interesting question, and I agree with Toshi. I think in the water chapter evaluation also, we concluded that adaptation has many benefits, but the evidence of risk reduction, basically whether it's reducing vulnerability, exposure, or hazard for those adopting those adaptation is still something limited, and I hope that many of the students sitting in this auditorium would think that it's a worthy enough topic to take up for their future studies and dissertation, because that indeed is a huge knowledge gap. We don't know how well adaptation works and how does one compare with the other. But overall, I think our conclusion is that it can't be just one thing or the other. You just simply cannot say that we have adopted, say, heat resistant or certain kind of seed that is good for a higher temperature, because the farmer at the same time experiences heat stress, and a couple of months down the line, they then also experience floods. And after a couple of months, they experience a price shock. So, what's happening is it's not one or the other. It's not, so the adaptation options that combine a lot of these options is what seems to be working the best. So it has to be a combination of more of these genetic varieties, but also better agronomy practices, better water management, on-farm water management, and all of those. So you just simply cannot put all your eggs in one basket, so to say. It has to be a really diversified adaptation option, very much like the diversified farming that Toshi was mentioning. Yeah.
Yeah, great, thank you. And to me, this brings up also, Rachel, the point that you made about the role of indigenous knowledge in adaptation, indigenous and local and practical knowledge. I can't think of any group of people who are experience more risk on a day-to-day basis than farmers, right? And that was true even before the advent of climate change. And so I'm curious if you have anything to add there, Rachel, about what specifically we could learn from indigenous knowledge or farmer knowledge, practical local knowledge that would help us shape these adaptation responses that will have multiple benefits.
Yes, it's a great question, and we did an assessment of indigenous knowledge as it applies to agriculture and food systems, and found a wealth of literature supporting the statement that it can be a really effective, not just tool, but group of people to really draw on and learn from. So I think one of the things that is important is thinking about the adaptation strategies being context specific, even though we have these broad categories, where we might talk about agroforestry, or we might talk about water management on farm, or we might talk about irrigation. There's a wide range of strategies, but having them be context specific and be adapted to the local agroecosystem and the local socio-cultural context, I think drawing on indigenous knowledge and local knowledge that is, really familiar with that context and can help make sure that it's really appropriate, and who may have strategies that haven't been thought of in other places. Or haven't been thought of by external actors, or that there's very little known about. So I think that is one of the important features, this kind of deep knowledge and expertise that's been built up over many generations in the context of indigenous knowledge, that really, although it's been recognized in previous IPCC reports, I think there continues to be lack of adequate recognition for the value that it and they as people really bring to the table. So I think that's one of the core messages of the report.
Thanks. That's fascinating, and we could talk about that a lot more. But in the interest of time, I'm going to shift a little bit, and I'm going to ask the panelists one more question that you can each respond to, and then I want to open it up to questions from the audience to make sure we save time for that. I'm curious if each of you, I think one thing about the IPCC reports is sometimes they can come across as being fairly high level, right? They're global in scope, and so there are these really big picture messages. And sometimes it's really helpful for us to kind of ground those messages in examples or kind of specific, as Rachel was just saying, agriculture and water management is very place-based and very specific. And so I'm curious if each of you could share with us an effort toward climate mitigation or adaptation in the food and water sector, one or either, that is inspiring you right now, and what you think we could learn from that example as we attempt to grapple with this very challenging kind of question. And so I think I'll turn to maybe Aditi first. Would you like to kick us off? And then Toshi and Rachel can chime in.
Yeah. Thanks, Maggie. I just wanted to reflect on some of the work that I am doing along with a lot of colleagues from IMI and the CGIAR on adoption of solar irrigation pumps. Basically, in the part where I work in South Asia, we are the largest user of groundwater. Like basically 1/4 of the world's groundwater is extracted and used in South Asia using some 20 million wells. So these numbers are really staggering for most to even imagine. So these 20 million wells run on either diesel or electricity. Electricity is often fossil fuel based. So there is an effort by the governments in these countries to replace these pumps, diesel and electric pumps, with solar irrigation pumps. And I think that's a very neat way of both mitigation and adaptation, because of course it reduces emissions of carbon, but it's also adaptation because in places where irrigation is not constrained by lack of water, these pumps can play an important role. But even in places where irrigation is constrained by lack of water, providing proper incentives can actually provide farmers an alternate source of income and provide them incentive to save groundwater. How that happens is, what's happening increasingly is that these pumps are being connected to the grid, and then farmers are being offered money to sell electricity to the grid. So farmers are making the trade-off whether to irrigate or whether to generate electricity and sell to the government. And this also has a very nice climate justice angle, because some of these farmers are at the forefront of climate impact. They live in areas that are very, very drought prone. So they are actually in an intense drought year, they no longer use groundwater. Instead, they are selling their electricity to the government. And we found that this income can sometimes go up to, on an average is 15%, but it can go up to 50% of a household's income during those drought years. So I think these are the kind of innovative things that we have to think out of the box, that a solar pump that also provides the opportunity for farmers to be energy producers rather than just food producers. So that's what's exciting me a lot these days. But there are issues. How gender inclusive is it? Is it including small marginal farmers? How can we include them? So those are all the big questions that I'm looking at right now. Thank you.
Yeah, that's a super interesting example. And Toshi, did you want to jump in?
Yes, I want to raise a little bit different issue. If you can see my background, there is a rice paddy, I think that produces methane. I think this is talking about the methane. I think reducing methane has multiple benefits. Well, that's produced from livestock and paddy field, and that's really agriculture related. But this methane has warming power. That's a really highly global warming pattern. But at the same time, it plays as a precursor of ozone. That's the photochemical oxidant that reduces crop yield. So the reducing methane by, say, water management in the paddy field and livestock feedstock on this is tremendous impact of mitigating global warming, at the same time reducing the negative impacts of ozone produced by methane. I think this new study from the AR6 cycle found that this reducing the methane from the agriculture sector is very important and effective. And so that's something I want to raise much stronger impact, the focus. And this was also raised in working group 1 and working group 3. I think this methane emission reduction is really, really relevant in reducing the global warming and also the impact of crops. So that's multiple benefits that I would raise. Thank you.
Yeah, interesting example. Rachel, did you want to add another example for us to consider?
Sure. It's great to hear these examples from Aditi and Toshi. I mean, my own work is really focused on agroecological approaches as applied by smallholder systems in sub-Saharan Africa, and I find that quite inspiring because it has this multiple benefit of addressing food security, nutrition, and livelihoods for smallholders, but it also strengthens resilience in terms of soil health being improved, diversification, so greater, reduced risk from impacts from climate change. And in some cases, there can be mitigation as well from things like agroforestry. So I find that very inspiring. And I do a lot of work with smallholders who really are, I think, at the cutting edge of some really innovative science. But I do want to mention as well shifting diets. It's maybe not as catchy as some of the examples that Aditi and Toshi have put forward, but from sitting in North America here, that's an important and really important message for those of us in the privileged position of eating more greenhouse gas emission heavy foods than is good for our health and that is good for the planet. So of course, beef is one of those foods, and there are other foods. We've got a wealth of literature. This wasn't a major focus of our chapter because we were on the adaptation side, but we did note that shifting diets can have many co-benefits in terms of adaptation as well as mitigation. And of course, Working Group 3 spent time looking at the mitigation impacts from shifting diets. That's not writ large. That's not everyone. Not everyone consumes more greenhouse gas emission heavy diets, but those of us who do, that can have a very significant impact. And if there were enough policies in place to really implement that at institutional levels and at regional and national levels, that could really turn the tide in very significant ways while having very positive impacts in terms of people's health and well-being.
Yeah, thank you. Yeah, it's good to keep in mind the breadth and consider kind of the food system as a whole and not only kind of how food is produced. That's a really important point. Okay, at this point, I am hoping that we have some questions from the audience that folks want to address. Yep, go ahead.
I just have a question when it comes to shifting to sustainable agriculture, because I know that the industrialized method that we have of agriculture, at least in the US right now, feeds a lot of people, and that there's a lot more work that's put into a lot of different models of sustainable agriculture. How would you predict that we can shift to sustainable methods of agriculture without necessarily depleting what is required for food for like the global population?
That's a good question. Did the question come through okay?
Yes. Toshi, did you want to take that, or do you want me to try it, or Aditi?
Rachel, you're the person who can answer that question.
Okay, thank you. Thanks. So, I mean, I answered that a little already, actually. One of the pieces in place. So if we shifted to more sustainable systems, the way we currently grow food isn't sustainable, not only in terms of greenhouse gas emissions, both in fertilizer use, in our transportation methods for, in sort of the methane that's produced, but also in terms of biodiversity loss, in terms of water pollution, and in terms of our health. It's actually killing us in greater numbers, the way that we grow food and the way that the kinds of foods that are being produced is not healthy for people either. So there's a need to shift not only for climate change, but also for these other reasons. And one of the ways to do that is by shifting diets. So if we were eating less highly processed food, which isn't so good for us anyways, and if we're eating in the global north and many parts of the global north and high income households, if we are consuming less meat, then that would have significant impacts on the climate side as well. So that's part of the picture. And there have been modeling done to see what would happen if we transitioned towards more sustainable agriculture. In order for it to be successful, we do have to shift diets in some places and for some people, and we also have to reduce things like food waste. But it is possible to make that transition, and still, feed the global population. That would be my short answer. And Toshi and Aditi, feel free to correct or add.
Right. I don't have any corrections, but I just want to add one aspect. The sustainable agricultural production really doesn't necessarily mean lower productivity compared to the current conventional one. And if you find a way to manage it, I think it's almost comparable. You can be sustained. But the challenge is it's not easy, and you need to have more higher skills, and you have to have the higher skills and knowledges. So that's a major challenge. And also some efficiency is a problem. So I think they try to enforce that the sustainable production. I think needs some support to engage in the production, sustainable production. That's the only thing I would like to add.
Yeah,
I'd like to support you, Toshi, and say that policies will play a very important role here. Often our policies are the ones that are giving perverse incentives. So in the context of India, what's happening is our breadbasket is these states which literally are running out of water. So we are growing very water-intensive crops in very water-scarce region. And I understand India is not an exception. Similar things may be happening in the US or in Europe, where a lot of the food gets grown with irrigation in very water-scarce region, while you have other regions where there is a lot more water, but because of various kind of policy distortions, food simply doesn't get grown. So actually matching the agroecological zone, what can be grown where, like traditionally used to be, it itself is a good answer. And these food systems are not that old. I mean, in India, the food systems I'm talking of are like 50, 70 years old. Before that, many of these food systems were very closely matched with their natural agroecological zones. So the drier zones grew things like, millets and coarse cereals, while the wetter zones grew things like rice and wheat. But now, because of irrigation and all other distortions in the system, it's possible to grow anything everywhere. So I think those are the kind of policy changes that we have to really research and kind of lobby and talk to the governments with.
Yeah, so a key role of policy there. That's interesting. I'm looking to see, do we have other questions in the room here? Oh, I'm seeing a lot of questions. Okay, I think we probably have time for a couple more. Maybe let's take one from this side of the room that we haven't heard from yet.
Hi, thank you. So this was brought up a little bit in the last session about the land and ecosystems as well, but a big part of food and water production that often gets kind of overlooked is farmers, and it was brought up a lot here as well. And I guess my question was in regards to the balance between smaller farmers versus like corporations and industrialized farms, and are they involved in the conversation? And if not as much as they should be, how can we start bringing them to the table?
Interesting question. Do we have anyone who'd like to jump in first on that one?
Go ahead.
Where I come from, majority are smallholder farmers. Though corporations are increasingly playing an important role in terms of aggregation models, they're often buying things in bulk. But overall, the context here is very different. It's really smallholder farmer, and they often are quite strong lobbies. They manage to organize and, even sometimes oppose many of the government policies that they think doesn't suit their interests. So I'll look forward to Toshi and Rachel maybe answering more on the corporation side.
All right. Here in my country, it's almost all the farmers are really small holders, and I think it's a little bit hard to say at the point, but I think the somehow mechanism by which this more of the farmers, not the different sizes, can be incorporated to design, co-design and co-work is a really crucial. I don't know. It's really, I can't give you any straightforward answer how we can do that, but I think that's the mechanism something we have to think of in the future. Sorry, I can't give you a really good answer at the moment. Thank you.
Yeah, it's great to hear Toshi and Aditi's perspective, because one of the things we highlight in the report is that smallholders play an important role globally in food production, including providing a lot of the diverse foods that are provided. In many regions of the world, they're the majority, and yet they are sometimes sidelined and politically marginalized and overlooked. Of course, in North America, the majority of farms are much larger, and that has been in part through very active policies which have shifted the sort of the landscape as far as farmers go. But in my experience, both in Africa and here in North America, farmers are very interested, even if they're not using the language of climate change, they are observing changes in their landscapes and in their farming systems that make them very interested in taking action, because they see the variability and their own vulnerability to the kinds of shocks that Aditi talked about, the floods one moment, drought the next, price changes, and this makes them quite vulnerable. So even if they're not using language terminology around climate change, they are interested in being involved in changes that support their livelihoods. So I think that it's critical that they are involved in the conversation and involved in actions.
Great, thank you. And, it's unfortunate. I saw a lot of more hands, and we could continue this conversation for a very long time. It's a big topic with a lot of areas to explore. But I hope that today gave everyone sort of a taste of some of the issues in this area of food and water in relation to climate change. You heard from our panelists some promising areas for students to get involved in through their research and studies. So I hope you'll keep that in mind. And let's go ahead and thank our panelists one last time for being here.
Thank you very much. Just some quick reactions to the discussion. This was a fabulous panel. Rachel is correct that in terms of when you look at acreage in the United States, more of that acreage is in large farms. But in Cumberland County, and this is not unusual, about half of our farms produce about $10,000 in revenue per year. Half of our farms. Now, they don't account for a whole lot of the acreage, but we have a lot of smallholder farmers as well. And that question about farmers engaging in these conversations, the USDA's Natural Resources Conservation Service has technical service providers who engage with farmers talking about these issues. They don't use the language of climate change typically. That may be changing now with USDA's adaptation policies. Penn State Extension Services, providing a lot of, resources, knowledge about cover crops and doing things to improve soil health. That was one of the things was talked about of strategies for adaptation that aren't dependent on high certainty about a specific future climate, but as one of you improve soil health, you're building resilience to a lot of things. So enough from me on that. Thank you all for attending this session, both our in-person audience here and the virtual audience. Our next session will begin at 3 o'clock. It is on cities and climate change. And so I'm looking forward very much to that. For those of you who are physically here in person, we have coffee out in the lobby. Please come and join us for that. For those watching virtually, please enjoy a cup of your favorite beverage. Thank you. Grab my stuff back.
Oh, sure. Yep.
Yeah, that was one of the things which, in doing the project with the Baird Fellows, realizing it's half these farms, now these are folks who are earning income in other ways,
Well, but the thing is, that's true for the majority of farmers, regardless of scale. Even big farmers often have other sources of income at this point. So I think it's a really interesting thing that, Pennsylvania is particularly that way relative to a lot of other parts of the country.
get to the Midwest, it's like,
it gets
yeah,
really
you
big.
could drive big tractors.
But it's interesting when Aditi was talking about, how smallholder farmers in India are really organized and actually involved in the political process. In Pennsylvania, Amish and Mennonite farmers actually are a pretty significant political force. Like they've organized effectively to.
I mean, it's changed over time. Like I went to college in Minnesota where it was still the Democratic Farmer Labor Party. I don't think it still is anymore, but it was like the history of that part of the world was farmers were a driving force in the Democratic Party.
Yeah. It would be great if we could change that back. In my opinion, you don't see that as much now. But come on, Nick.
Good job, Maggie.